Hello friends, now let us see the Taylor series. Now this Taylor series is used to find the approximate values of sine, cos, tan, tan inverse and all. And in this the first function which we will see is sine of x. Now sine of x is equal to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on up to infinity. It goes up to infinite series. It is an infinite series. And the value of x is in radians. The value of x is in radians. Now as soon as we see the series, what are the observations that comes to our mind? That is, the first observation is, it is the alternate plus and minus sign. Once it is plus, once it is minus. Once it is plus and once it is minus. And this x can be written as x to the power 1 divided by 1 factorial. Now if you see the powers of x, the common difference of the power of x is 2, 1, 3, 5, 7, and the common difference of denominator, I am not talking about the factorial, only the denominator 1, 3, 5, 7, and we take that as a factorial. We take that as a factorial. Now we know that it is an infinite series. Can we compute till infinite times? No, we cannot compute till infinite times. Then how long we compute? Till that long where the two terms converge. It means if I take some sine of x, if I take sine of x till x to the power 7 by 7, that is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial. And again if I compute sine of x till x raised to 9 by 9 factorial, this is just an example I am taking, plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial plus x raised to 9 by 9 factorial. It means if these two terms converge, that is, the absolute difference between the two terms is very less. Now we need to take something called as an epsilon value or the error range which is permissible to us. Now if I say the error range that is permissible to us is 10 to the power minus 3, that means we need answer accurate to 3 decimal places. Now if I say error is 10 to the power minus 4, we need error range up to 4 decimal places. That means up to 4 decimal places we need the correct answer. Now if suppose the sum of this one, I call this as S1, and if suppose I call this as S2, and if the absolute difference between S1 and S2 is 10 to the power minus 3, if I want to take the range of the error as 3 decimal places, then we stop the procedure. That means we go on doing it till it converges. How long we go do it? We do it till it converges. And the error range you can take it to be anything, 10 to the power minus 3, minus 4, minus 5. The smaller the error range, the more accurate the answer will be. Now let us take the error range as 10 to the power minus 3 and compute the sine pi by 2. And we know that sine pi by 2 is 1. Is that okay? And what is the value of pi by 2? Pi is 3.142 divided by 2 is 1.578. Why we have taken only 3 decimal places? Because we need accurate to 3 decimal answer. Now how do we compute it? Already I have written the answers and computed it. Now first what we do, we say sine of x. You take the first term. What is the first term? X power 1 divided by 1 factorial is x. Now it is equal to 1.578 because the value of x is 1.578. It's in radians. Now if it is 1.578, it is the first term. Now what did I say? You find sum till this point, we called it as S1, sum till this point we called it as S2. Then you took the absolute difference. Now if I take the first term, what is the previous term? The value of the previous term to begin with is 0. Therefore I write here the value of the previous sum is 0. And what would be the value of sum? Since we are adding and subtracting, the value of sum should also be equal to 0. And whatever is there, whatever the value you get, you add it to sum. You say sum is equal to this particular value, sum plus this particular value. Therefore it becomes 1.578. And what is the previous sum? It is 0. Now you find the absolute difference. You say absolute of sum minus previous. Absolute of sum minus previous. What is sum? 1.578 minus 0 is equal to 1.578. Now we need accurate to 3 decimal places. It is 10 to the power minus 3. You need to check, is it less than or equal to 10 to the power minus 3? No, it is not less than or equal to 10 to the power minus 3. That means this is not the answer. Proceed further. This is not the answer and you proceed further. Now how do we proceed to the next step? Is that okay? Now when I take the next particular thing, these two terms I need to compute, x to the power 1 minus x cube by 3 factorial. Therefore, the previous sum will be equal to x to the power 1 by 1 factorial. And where did we store in the previous sum? We say previous gets the value of sum, that is 1.578. And we compute the next sum. How do we compute the next sum? We say sum is equal to sum plus, what is the thing? Minus x cube by 3 factorial. Minus x cube by 3 factorial. Now what is sum? 1.578 minus, it is 1.578 whole cube divided by 3 factorial is 6. And if I compute this, I have already computed this answer and have stored it. And if you compute it, the answer is 0.923. Answer is 0.923. Now again you need to find the absolute difference. And how do you find the absolute difference? You say sum minus previous. We say sum minus previous. And what is sum? Sum is 1.578. 1.578 minus, what is the value of previous? 0.923. It is 0.923. Now, if you get the difference of this, it is 0.655. It is 0.655. Is it less than or equal to epsilon, which is 0.001? No. Since it is no, therefore you need to compute the next step. And how do we compute the next step? See here, we say previous equal to sum. Previous equal to sum. And what is the value of sum? 0.923. Previous equal to sum 0.923. And we say sum is equal to sum plus. And you take the next term. And what is the next term? X to the power 5 divided by 5 factorial. We say x to the power 5 divided by 5 factorial. Now what is the value of sum? The value of sum is 0.923. We say 0.923 plus x to the power 5 is 1.578 whole to the power 5 divided by 5 factorial is 120, or you can just write 5 factorial. And if I compute this, we will get the answer as 1.004. We will get the answer as 1.004. Again we do sum minus previous. Again we do sum minus previous. What is the value of sum? 1.004 minus 0.923. Now what is the answer that we are going to get? 0.081. It is 0.081. Is it less than or equal to 10 to the power minus 3? No. Therefore, again you continue with the next step. And what do we say again? We say previous equal to sum. What is the value of sum? 1.004. And we say sum is equal to sum plus the next term. And what is the next term of the series? Minus x to the power 7 divided by 7 factorial. Minus x to the power 7 by 7 factorial. Now, what is the value of sum? It is 1.004 minus 1.578 to the power 7 divided by 7 factorial. And if you compute it, you get the answer as 0.999. You get the answer as 0.999. Again we find the sum minus previous. You say absolute difference of sum minus previous. What is sum? 0.999 minus, what is the value of previous? 1.004. And what is the answer you get? 0.005. You get 0.005. Now is this 0.005 is less than or equal to 10 to the power minus 3? No. Therefore, again you need to continue with the next iteration. And how do we say it again? We say previous equal to sum. What is the value of sum? 0.999. And we say sum is equal to sum plus. Sum plus. What is the next term? X to the power 9 divided by 9 factorial. X to the power 9 divided by 9 factorial, which is equal to What is the value of sum? 0.999 plus 1.578 whole to the power 9 divided by 9 factorial. And if you compute it, you will again get 0.999 accurate to 3 decimal places. It is accurate to 3 decimal places. Now you say sum minus previous. Now we say sum minus previous. What is sum? 0.999 and what is previous? 0.999, and it is equal to 0, which is less than or equal to 10 to the power minus 3. Therefore, I have to stop the procedure, and what is the answer? Whatever is there in the sum, that is the answer. Therefore, sin pi by 2, according to the Taylor series, up to 3 decimal places, the answer is 0.9999. Is that okay? This is how we do. Now, what we need to do? We need to take the previous value of sum 0, because we don't have any previous value, and the value of sum is also 0. Next, we take the first term, compute sum minus previous absolute difference. If it is less than or equal to epsilon value, epsilon you can take any value as 10 to the power minus 3, minus 4 or anything, that's your choice. If it is so, we stop the procedure. If it is not, then we say previous equal to sum, and we go on doing it till it becomes less than or equal to epsilon. Whenever it becomes less than or equal to epsilon, whatever is there in sum, that would be the final answer. This is how we compute the sine series, right? This is how we compute sine of x for the Taylor series. Now let's see how do we write the code for it. Thank you. Let us see how do we write the code for it. Now, if we clearly observe, we need two variables, previous and sum, and already I said the common difference is common difference is 2 in case of numerator and denominator. Therefore, we say here hash include stdio.h, and I write here hash define. We know that hash define is used to give the macros or the manifest constants. And what do we the manifest constant? It is the epsilon value. What is the epsilon value? We need it. We say hash define epsilon, and you can say 0.001. It is 10 to the power minus 3. And if you know it accurate to 4 decimal places, you say 0.0001. And what it does, wherever there is epsilon, it will be replaced by 0.001. We know that. Now, let's write the main function. What is the input for our question? Input for our question is x, and the value of x is in radians. Hence, we say float x. And we have to read the value of x in radians. Therefore, here I write printf enter angle in radians. You can read in degrees as well and convert that back to radians. I leave it to you for do that. And this is scanf %f ampersand x. Now you read the value of x. Suppose the value of x which you have given is 1.578. Suppose the value of x which you have given is 1.578. Done. Now you need the value of previous and you need the value of sum. And if you observe, it is 0.923. The previous and sum are the value of double, or you can take it as float. Since I have taken x as float, let me take sum as previous also as float. We say float sum is equal to 0, and what is the value of previous? And we say float previous also is equal to 0. These two are also done. Now after you read the value of x, do we know when does it will terminate? At what point it will merge? We are unaware at what point it will merge. And whenever we are unaware at what point it will merge, we need to use what? We need to use infinite loops. Therefore, we say while 1. Why I say while 1? Because we are not aware that when it is going to merge. Whenever it will merge, we will break from the infinite loop. Hence, let us start with while 1. Now, the first thing is you need to compute the value of the first term, sine of x. And how do we compute the term of sine of x? We say sum is equal to sum plus x. If I say sum is equal to sum plus x, First time it is x. Next time this x will change to x cube. Next time this x cube will change to x to the power 5. It means at each and every point, you are multiplying it by 10 into x square. You are multiplying it by x square. Suppose if I say y is equal to x. Next time, how do you compute x cube? You say y is equal to y into x square. Therefore, the value of y will become x cube. Next time, how do you compute x to the power 5? Y is equal to y into x square. The value of y is x cube into x square is x to the power 5. Next time, how do you compute x to the power 7? You say y is equal to y into x square. Therefore, you get x to the power 7. Right? And here I cannot change the value of x. If I change the value of x, right? Suppose if you write it like this, you might ask, sir, why can't we write x is equal to x into x into x? Now, what will happen at this point of time? The value of x will become x cube. The value of x will become what? X cube. That means you are changing the value of x. We do not want to change the original value of x. We want to retain the original value of x, whatever the user has given, so that while at last I want to print, I say sign of x. Right? You want to retain it. Therefore, we want to take one more variable y, and what do we say? We say y is equal to x. Now the value of y is same as x, or x is y. Therefore, instead of writing sum plus x, I can write sum plus y as well. Now, coming back to the numerator is done. Coming back to denominator, it is 1, 3, 5, 7, 9. Now this is 1 factorial. Now what is 1 factorial? 1 factorial is 1. Let's take long int. Let's take long int f is equal to 1. Now what do you mean by f is equal to 1? Because we want to compute factorial. And what is the factorial of 1? Factorial of 1 is 1. Therefore it starts from 1. Now we know that n factorial is equal to n into n minus 1 factorial. Needless to say, n factorial is n into n minus 1 factorial. Now, with the same relation, how can I write n minus 1 factorial as n minus 1 into n minus 2 factorial? Is that okay? Therefore, if you want to compute n factorial, you can say n into n minus 1 into n minus 2 factorial. Suppose I want to compute 3 factorial. How can I write 3 into 2 into 1 factorial? Is that okay? And already I have the value of 1 factorial. And if you want to compute 5 factorial, how can you write? 5 into 4 into 3 factorial, and already you have computed the value of 3 factorial. And if you need 7 factorial, how can you write? 7 into 6 into 5 factorial, and already we have computed 5 factorial. Therefore, this f equal to 1 represents 1 factorial. Now, if you have here 3, you need here 3 and 2. You need 3 and 2. Already you have 1 over here. That means we need to take one more variable, and let us take int I is equal to 1. Let us take int I is equal to 1. If I is equal to 1, we will compute 1 factorial. Next time I will become 3, we will compute 3 factorial. Next time I will become 5, we will compute 5 factorial. Next time I will become 7, we will compute 7 factorial, and so on and so on. Now, therefore, sum is equal to sum plus y divided by, you need 1 factorial, and where 1 factorial is available, it is available in f. Therefore, we say divided by f. We say divided by f. Now, it is alternating plus and minus sign. It is plus, minus, plus, minus, plus, minus, plus, minus. That means, if the first term I multiply by 1, second term I should multiply by minus 1, third term I should multiply by 1, fourth term I should multiply by minus 1, and so on it goes on. Therefore, let us take one more variable called as sign. Let us take one more variable called as sign. If sign is 1, we will multiply by 1. If sign is minus 1, we will multiply by minus 1. Hence, I write multiplied by sign. Hence, I write multiplied by sign. Is that okay? Now, let's see what does this particular thing, the first term, gives us the answer. What does the first term gives us the answer? Okay, just a moment. Now value of sum is 0, the value of previous is 0, the value of f is equal to 1, the value of I is equal to 1, and the value of sine is also equal to 1, and the value of sine is also equal to 1. You read some angle, we don't mind it, and we say y is equal to x. Y gets the value of x. While 1, it is true, sum is equal to sum plus. Sum is equal to 0 plus y by x, y by f. Y is x divided by f. F is 1 multiplied by sine. And what is sine? 1. X by 1 into 1 is nothing but x. X plus 0 is nothing but x. Therefore, sum will become x. Now you have got the first term. Now after you get the first term, you need to find the absolute difference of sum and previous. Therefore, let us say a is equal to, now for absolute, there is one function called as ABS, and that ABS is only applicable for integers. I have said already in mathematical functions. I post the video link in the description section. Please go on. And for the floating point number, we use something called as FABS. We use something called as FABS, and it is in math.h. Hence we say A is equal to FABS of sum minus previous. We say FABS of sum minus previous, and I have to declare a variable A. Let me declare a variable A. Now this is what you find, sum minus previous. Now you need to check, is it less than or equal to epsilon? If it is less than or equal to epsilon, I should stop the process over here. Hence we check if A is less than or equal to epsilon. That is what we have defined, epsilon. If it is so, we will break from this infinite loop. We will come out of this infinite loop. After we come out of the infinite loop, where is the answer stored? Answer is stored in sum. Therefore, you can say sine of x and so on. I am directly printing sum over here. You can print sum and you say return 0 and you can stop. Now, if it is not less than or equal to epsilon, what we are doing? We are saying previous gets the value of sum. That is what I need to write over here. I say previous gets the value of sum. We are preparing for the next iteration. Now, after we say previous equal to sum, what should be numerator? X cube. Numerator should be x cube. And what is numerator over here? It is y. Y is x. Now it should become x cube. And how do we make y as x cube? Y is equal to y into x into x. We say y is equal to x into x into x. Now y is x into x into x is nothing but x cube. Next, you need 3 factorial over here. You need 3 factorial. Therefore, I can say f is equal to, f is 1 factorial multiplied by 2. And how you can get 2? You can say I plus 1 multiplied by I plus 2. You can say multiply by I plus 2. Hence, what do I write over here? F is equal to f into I plus 1 multiplied by I plus 2. Now, if you observe here, the value of I is 1. 1 plus 1 is 2, 1 plus 2 is 3, and the value of f is 1. Therefore, f becomes 3 factorial. I can write f as 3 factorial. Next time we want to compute 5 factorial, and if I want to compute 5 factorial, f is 3 factorial. What do I need it over here? I need 4 into 5. Now, if I plus 1 is 4, the value of I should be 3. And how do we make I is equal to 3? We say I is equal to I plus 2. We say I is equal to I plus 2. The value of I will become 3. And this numerator is done, denominator is done. Now multiplied by sine. Now sine should be minus 1 because we have to multiply by minus 1. Hence we say sine is equal to minus sine. Hence we say sine is equal minus sine. The value of sine will become minus 1. Go back. Y1, it is true. Sum is equal to sum plus y by f. What is y? X cube divided by f is 3 factorial multiplied by sine. What is sine? Minus 1. Therefore, it becomes minus x cube by 3 factorial. Now, again you find sum. Okay, I have forgot to do this step. Previous equal to sum. The value of previous will be x. Now, you do these two subtract. Is it less than or equal to epsilon? Let us assume no. Then again you say previous gets the value of sum. previous gets the value of sum. Y is equal to y into x, y becomes x to the power 5. F is equal to f into, f is equal to f into. Now what is the value of f? 3 factorial into I plus 1. 3 plus 1 is 4. I plus 2, 3 plus 2 is 5, and this is equal to 5 factorial. Therefore, the value of f will become 5 factorial. I is I plus 2. The value of I will become 5. Sine is equal to minus sine. Sine will become 1. Go back. Y 1. Sum is equal to sum plus. This is sum plus. Y by f. Y is x to the power 5. Divided by f is 5 factorial. Multiplied by 1. It is plus itself. Next, again you say previous minus sum, and assume that it is less than or equal to epsilon. We bracket and you print the value of sum, and you can see here that we are generating the Taylor series. And how long we should generate? Till how the long they are going to converge. They are going to converge. And if you take the larger value of epsilon, the answer will be more accurate, more accurate, and more accurate. If you want up to 4 decimal places, you can write 0.0001 and the answer will be more and more accurate. This is how we write the code for the sine series. I hope you have enjoyed this video. If you have enjoyed this video, please like this, subscribe to my channel, and you may share this channel with your friends. Thank you. Thank you for watching this video. For the online paid courses of C programming, data structures using C, and analysis and design of algorithms, you may contact at the given email ID, and you may download the following app. The app link is being given in the description section. Thank you.